We know what you're waiting for. G'day guys, Matt from Hal Heavy Duty. We're an Aussie machine shop that specialises in the drilling industry. And what we're doing today is we're building a saver sub for the drill string of our big rig. Now this rig is designed to take a 3-metre Megadrill 250 metres into the ground. So that's 10 feet wide for my American friends, 800 feet deep. It is quite literally off the charts. Now what we're building here is a saver sub. So what it does is it screws onto the head itself, this part here, and it's just a short connection that's a female connection or a box to a male connection, we call pin. It's a box to pin connection where all it does is just lets this be the thread that wears out rather than this one, because it's going to be what screws into every single rod. They're like a throwaway item, they're just a really big one. We can occasionally recut them, which is what we try to do to save on material, but this will be the largest one we've cut in 60 years. So I'm really looking forward to today's video. If this is your first time on the channel, consider subscribing. We do a weekly video and it just gives you a little window into our world. So anyway, let's get into it. Now before we get started, I'm going to give you the commentary as to exactly what I'm doing, but then we're just going to let it machine, and I've included some sped up parts just so you can get an appreciation for how long these things take to make. This is about 400 kilos or 900 pounds worth of steel here. It measures 320 mil in diameter and about 650 long. For my American friends, it's a foot in diameter and 2 and a bit feet long. And the first thing we're going to do is stick it into our big green Megabore lathe we call the Hulk. We're going to face it. We're going to just turn down a little shoulder, because then we're going to be using our big trepanning bit, our big core drill, to take out a big core out of the center of it so that we can reuse that billet. A lot of you have commented in our previous videos like, why are you always drilling it? And the answer is most of the big stuff we've been doing recently is too long. So this particular part is just perfect. Our trepanning bit's just big enough to do it. And so that's exactly what we're going to do. We actually have to do a little modification on it first, which is we've dialed it in, as in we run a dial indicator along the nose of it there to make sure it's running completely true. But last time we ran it, there's a bit of an issue with the tips were not touching at the exact moment, which made it vibrate a little at the start, which is not ideal. So we're just going to readjust, because you've got to have it where both inserts make contact at the exact same time. We're just doing a little adjustment here, and we're going to re-weld in this little particular little stopper here. We're just going to grind that out a little tiny bit more, but once it's welded in there, the tool will be ready to go. We're paying attention to a few things when we trepan. The first one is the chips that are coming out. That'll tell you a lot. They usually come out a golden blue color. This doesn't have coolant that goes directly onto the tip, so that whole chamber has to fill up first. If I build another one, which we will be putting coolant straight to the tip if possible. I've been watching a bunch of David Wilkes' old videos, and man, that guy's just, his channel's great. But that amp meter you can see there, if it draws 20 amps, that means we've broken an insert. So between listening to it, watching your chips, and just keeping an eye on that little dial, it'll let you know how it's performing. So this whole billet will go about a foot in from one side and same from the other, and then we'll come out with a nice big slug, which will get reused, and we'll build two more drill subs out of that. So it's a win-win, and it's very quick too. The trepanning is very fast. Like once you get it all set up, it just cores this out in no time. you could both hear and see. We've chipped an insert most likely. Don't usually break them, just a corner chips off or something, which is no big drama. It will still cut, it just won't be nice. And you can see right there in the right hand corner. So we'll just quickly index that across and then we'll be back coring. Before we send this over to the CNC for final machining, we're just going to do a quick finishing pass with Tiny. Tiny's the biggest boring bar in the shop, and it'll do that in one quick pass, and it'll just mean we can hog into it faster with the Beast, which you'll see in a sec. You can see it's starting to take rough form now. So what we're going to do is head over to our CNC. It's a Colchester Alpha 1760, where we can start machining out all the rest and putting the threads on. So now that it's in the CNC, I'm going to turn down the entire outside to its exact finished size, put a steady on and then face it, and then we're going to use the Beast to hog out the inside, 475 deep, so 1.5 feet. Then we're going to cut the box connection with a different bar, flip it over and do the pin. This video is really going to highlight the 3 boring bars I've used the most in building all of this. 3 of them, the Beast, Battle, Kong and Kong. The Beast is the biggest and this thing absolutely hammers. We're going to be taking some really good heavy cuts with this. Then we're going to create, that's just to hog out the inside. We'll then use what we call Battle Kong. This was designed to battle the really interrupted, crappy conditions that came with some steel we bought from overseas that was hollow bar 4140. So it's a pretty gnarly looking bar, but it's perfectly designed to actually cut the box connection itself. And then we'll be using Kong, which is even shorter, to do the pin side of things. You'll see why in a sec. All right, well, let's get into it. Right, for the next step we need to install our cross slide tool holder. You can see how we built this in a previous video, but this little bird box has really allowed us to maximize what we can do with what's essentially a medium-sized lathe. This has allowed us to put some really heavy-duty tools in and do some stuff that the lathe really wasn't designed for, but it works. We now get to run my favorite shop-made tool, which we call the Beast. It's a KM80 headed 95mm bar, or 3 3/4 inches. It weighs about 40 kilos or just under 100 pounds. And we purely use this thing for deep parts where we've got to hog out lots of material. I'm going to be trying out a different insert than normal. Usually my go-to is just a general machining which has a medium negative chip breaker on it. I'll explain that in a second for those that aren't machinists. However, I'm going to be using a heavy roughing insert. It's a roughing positive. So it just allows me to take heavier cuts and higher feeds. So we'll see how that goes. What they mean by the chip breaker is it's just the angle of the very edge of the insert. The little part that helps the steel come off. It can either be positive, neutral, or negative, and I'll show you what that looks like. We'll zoom in on it. With the general machining or the medium negative insert, you can see on the very right hand side of the tip there, it's angled down ever so slightly on what's called the chip breaker. And it just means it's a very robust insert, but you just can't run it as hard. I mean, we still get really good results with these. I just want to try something a little bit different. Go over and have a look at the roughing positive insert. You'll see that when we zoom in, and I'm apologizing in advance if it's a little shaky, but if you zoom in, it doesn't actually angle down, it actually angles up ever so slightly. It looks like a little scoop, and it just means that it'll chip off better and you can run it harder. So we're going to have some fun with that. And the reason why I really like CNMG tips for roughing, particularly on boring, is that even when they break, like this is the swarf that came off a broken insert, they tend to cut really well. Like I've broken only a handful recently, and they still keep cutting. Like you can tell that it's broken because your spindle load will go up and this sort of swarf starts coming out, but they do a really good job. So let's swap these out now, and then we're going to get in and do some hogging out with the Beast. So even though the Beast is hanging out 475mm or a foot and a half, it can still take 5mm cuts without any vibration. 5mm is about 5/16. So it's a relatively heavy cut considering how far it's hanging out. I will be playing with the feeds and speeds a bit because it's the first time that I have run this particular insert. But you can see the cutting data here. We're going to do 2 5mm passes, and then we're going to do a finishing of 2.5mm. You can see the difference between a 5mm cut and a 2.5mm cut there in the swarf size. That's a fairly heavy cut considering what we're doing, but chipped off beautifully. I'm really happy with that insert. I think it's going to be my go-to for the Beast. Maybe not for the other bars, but certainly for this one. Really happy with it. Before we thread it, I've just got to put a quick circlip groove in, and we're going to use a top-notch grooving tool to do that. We're going to be using a Kennametal top-notch threading bar to cut this custom box. It's a 3 TPI thread with a 3-degree taper with both a primary and a secondary torque shoulder, because it has to handle some insane amounts of stress, being that it's driving a 3-meter drill. So I'm going to speed some of this up, same as before, 10x, just so that you can get a feel for exactly how much work goes into these. There's over 30 passes to get one of these threads to depth. Right, now that the box connection is cut, we're going to flip it over, put the pin on, and the first thing we've got to do is take out the inside, and then we'll put a center up it and also keep the steady on just to minimize vibration, and then we will cut the pin and thread it. Because the thread's flat bottomed, I can actually use this tool. It wasn't my idea originally, but it actually works pretty well. I think it's a tire tread gauge, but you can see there it's 2.8 mil deep. We've got to go a little bit more yet, so we'll carry on. The finish on that's come up really nice. We've played around a lot with like number of cuts, methods of programming and cutting, and we've found that if we just run it a little bit slower than you think, the finish is much, much better in the end, and you don't get chatter and you don't have to do endless amounts of final cleanup. I'm just going to run a tiny little bit of emery cloth. I don't like running long bits of emery cloth on lathes, but I don't mind doing it like this just to give it that nice finish. Then we're going to test this, and we're almost done. So these testers were actually built as the prototype when we were designing up the thread, and I cut an inspection window into them just so that we could see that the threads were engaging properly, that we had enough clearance on the top and the bottom of the thread, just because out in the field they're going to get dirt and crap in there, and there actually needs to be a little bit of a void to allow for that. This is the primary shoulder. It's going to engage first. We check that by just putting a little piece of paper in there, and the bottom shoulder, so you'll see there's the primary shoulder that's engaged, and the bottom shoulder will have a 0.15 gap. So as long as that's just a little bit loose, it means that the primary shoulder engages first, then the secondary, so that you get maximum torque on that top shoulder. I'm really happy with that. It's the largest sub we've cut in 60 years. And we've finally given the thread a name. It's being called a HAL 316 box. 316 because that's actually the final outside measurement. And we call it that simply because out in the field, they're just going to be able to whip out a tape measure it and go, oh, the outside of it's 316 mil. That's just field stuff. We could have been more complex like all of the API stuff, but we're just pretty practical. And named it after my grandfather, Hal. He started the company 60 years ago. And, you know, he was a guy who at the age of 14 was working on the back of a drill rig in Canada and had drilled in Beirut, Lebanon. He's drilled in the Simpson Desert, Arctic Circle. And at the age of 60, he just decided, I don't want to drill anymore. I want to be a machinist. And for the next 27 years, he was found behind a lathe and just loved it. So we miss him all the time, but you know, I think he'd be real proud of what's going on these days. Just for a bit of comparison, that's a 2 3/8 IF thread. It's 90 mils in diameter next to the HAL 316 thread. These are ginormous. They're much larger than an 8 5/8 reg. They are just huge because they have to have an inner tube go up them in the rods. So let's fingers crossed this is going to handle the insane torque that the Megadrill produces, and you're going to see that in a future video. I'm really excited. We're getting close now. I'm really happy with how that all turned out. So that's the largest crossover sub that we've ever made in this shop. It won't be the biggest because there's another bigger set of drill rods already been ordered, which is insane. So that's coming. But you'll notice that when we're doing the trepanning with the big core drill, it's hung off this tool post. In a future video, probably either late this year or early next year, we're actually going to be building an entire custom tool post riser here where we can directly insert both drills and trepanning bits. and also run big bars, because one of the things is this is where the lack of rigidity occurs. So that's coming in a future video as well. So I'm really excited to upgrade the Hulk like we did with the CNC. You'll see in the video, like the Beast just smashes it out compared to Tiny, which is the boring bar that was going up the center of this, just because the rigidity of the tool post. So we're upgrading all the machines as we go. In a perfect world, it'd already be done, but they just keep bringing in bigger stuff, so we've got to keep upgrading everything as it goes. So anyway, that's it from me. One thing I'd like from you guys, if you don't mind, you know, when I started this channel, I actually gave Karen from Cutting Edge Engineering a call. I've known Karen for a while, and just said, hey, look, can you give me any tips? And being the darling that she is, she said, yeah, of course. She said, pay attention to the comments, because they'll tell you where you're screwing up. And you guys have been great. I look forward to the comments every single week. I either learn something or get some encouragement, or some, you know, brutal feedback, which is totally fine, because I'm not a YouTuber as such, I'm a machinist, but I just like sharing the stuff that we do, because I think it's pretty interesting, and I get a kick out of watching it as I do it, but also it's just, I find it relaxing to watch. So my question for you this week is the level of commentary that I'm giving you, is it too much, is it not enough, or is it just right? Big Goldilocks for me. Tell me, is it too hot, too cold, or just right? Because my goal is not just like machinists tune in and go, oh yeah, this is great, and critique it. It's also that people who don't know that much about machining can tune in and watch and learn a little bit about it, but also get the joy of having uninterrupted machining time. So I'm trying to find the balance. If you guys could help me, that'd be great. Anyway, if you're new to the channel and you've enjoyed what we're up to, consider subscribing and liking the video. It really helps us grow. And to all of our returning viewers who have helped me so much to get from where we started, you know, just 6 months ago to 14,000 subscribers, guys, thanks heaps. I'll see you in the comments, and I'll catch you on the next one.